Manchester, England. The year is 1840. Joseph Whitworth stands in his workshop, staring at a table covered with bolts and nuts. Hundreds of them. He's collected them from factories across Britain, from textile mills in Lancashire, ironworks in Birmingham, shipyards in Liverpool. Every single one is different. He picks up two bolts that look identical, same diameter, same length. But when he tries to thread a nut onto the second bolt, after removing it from the first, it won't fit. The threads are slightly different angles. The pitch is off by a fraction. They're incompatible. Whitworth is 47 years old, and this problem has been driving him mad for years. He's one of the most respected toolmakers in England, known for his precision measuring instruments that can detect differences of 1/1,000,000th of an inch. But what good is that precision when every workshop in the country is making threads differently? He can see the future so clearly. Imagine if every bolt and nut in Britain, no, in the world, were made to the same standard. A broken machine in London could be repaired with parts made in Manchester. Ships could be built with components manufactured in different cities. Factories wouldn't need to custom make every single fastener. But convincing the world to adopt a standard, that's a different kind of challenge. What Whitworth doesn't fully realize yet is that he's standing at a crossroads in history. The screw thread, this simple spiral groove, has existed for over 2,000 years. But it's never been standardized. Every craftsman makes threads slightly differently, following their own judgment, their own traditions. It works, barely, but it's holding back the entire industrial revolution. In 1 year, Whitworth will present his standard to the Institution of Civil Engineers. It will be rejected, mocked, called unnecessary. It will take another decade before anyone takes it seriously. But when they finally do, it will change everything. The screw thread is one of humanity's oldest inventions and one of its most important. Without it, nothing stays together. No machines work, no buildings stand tall, no modern technology exists. And yet for most of history, every screw was a custom creation, incompatible with every other screw. This is the story of how a spiral groove became the invisible glue holding civilization together. It starts in ancient Greece, disappears into centuries of craft tradition, and explodes into standardized mass production. And at the center of that transformation stands a perfectionist toolmaker who couldn't stand the chaos anymore. The screw thread is ancient, really ancient. Around 400 BCE, a Greek philosopher and mathematician named Archytas of Tarentum is credited with inventing the screw principle. Archytas was a contemporary of Plato, sometimes called the founder of mechanics. He understood something profound. If you wrap a ramp around a cylinder in a spiral, you create a simple machine that can convert rotational motion into linear force. But the most famous ancient screw wasn't invented by Archytas. It was invented, or at least popularized, by Archimedes. In the 3rd century BCE, according to legend, Archimedes was asked by King Hero of Syracuse to build the largest ship ever constructed. The ship was built, but it had a problem. It leaked. Water constantly seeped into the hull, threatening to sink the massive vessel. Archimedes designed a solution, a large screw inside a cylinder. When you rotated the screw, it would lift water from the bottom of the hull and carry it upward, where it could be dumped overboard. The Archimedes screw, as it came to be known, was brilliantly effective. But here's what's important. The Archimedes screw wasn't really a fastener. It was a pump, a machine for moving water. The screw principle was being used to do work, not to hold things together. The ancient world did use screw threads as fasteners, but only in limited ways. By the 1st century BCE, wooden screws were common in wine and olive oil presses throughout the Mediterranean. A large wooden screw would be turned to press down on grapes or olives, extracting juice through sheer force. These screws were massive, hand-carved, and each one was unique. The Romans, master engineers that they were, used metal screw threads in some applications. Archaeological evidence shows small threaded fasteners in surgical instruments, jewelry, and precision mechanisms. But these were rare, expensive, and custom-made by skilled craftsmen. Why didn't the Romans use screws more widely? The answer is simple. They were too hard to make. Cutting a precise thread into metal by hand is incredibly difficult. You need to maintain a constant pitch, the distance between each thread, all the way around and all the way along the length. Any variation and the screw won't work smoothly. For most applications, the Romans found it easier to use nails, dowels, or mortise and tenon joints. So the screw thread existed in the ancient world, but it remained a specialized tool used only when nothing else would do. Then came the Middle Ages, and screw threads became even more specialized. Armor makers used them to attach pieces of plate armor. Gun makers used them in the firing mechanisms of early firearms. Clock makers used them in the intricate mechanisms of mechanical clocks. But each craftsman made threads according to their own judgment. There was no standard, no consistency, no interchangeability. By the 15th century, metal screws were being used in woodworking for the first time. The screwdriver appears in medieval manuscripts around this time, a simple tool that allowed craftsmen to drive screws into wood. But again, every screw was different. If you lost the specific nut that fit a specific bolt, you had to make a new one by hand. This is the world Whitworth inherited, a world where screw threads existed but were fundamentally artisanal, one-off creations. Every workshop had its own way of cutting threads. There were no standards, no specifications, no way to ensure that a screw made in one place would fit a nut made in another. For a hand tool economy, where craftsmen made individual items from start to finish, this was fine. But the Industrial Revolution was changing everything. Factories needed interchangeable parts. They needed to be able to order components from suppliers and trust they would fit. They needed standardization. And that's where Whitworth comes in. Joseph Whitworth was born in 1803 in Stockport, near Manchester. His father was a schoolteacher and congregational minister, and young Joseph was expected to follow a respectable professional path. Instead, he was fascinated by machines. At 14, he was apprenticed to his uncle's cotton spinning mill. This was the heart of the Industrial Revolution. Manchester and its surrounding towns were filled with textile mills, each one a symphony of spinning jennies, power looms, and steam engines. Whitworth learned how machines worked, how they broke, and how to fix them. But it was precision that captured his imagination. He moved to London and worked for several of the greatest toolmakers of the age, Henry Maudslay and Joseph Clement, learning the art of making measuring instruments and machine tools. Maudslay, in particular, was obsessed with precision. He had developed the first truly accurate lathe, capable of producing perfectly cylindrical shafts and precise screw threads. Whitworth absorbed everything. By the time he returned to Manchester in 1833 to open his own workshop, he was one of the most skilled toolmakers in Britain. He invented a measuring machine that could detect differences of 1/millionth of an inch. an almost unbelievable level of precision for the 1830s. But precision was useless if there was no standard to measure against. Late one evening in his workshop, Whitworth sat examining a collection of bolts. He had been gathering them for months, taking samples from every factory and workshop he visited. The more he looked, the more frustrated he became. The threads varied wildly. Some had 48 threads per inch, some 32, some 60. The angles varied from 47 degrees to 60 degrees. The shapes of the threads, whether sharp or rounded, were different. Every single one worked, technically, but none worked with any other. It was chaos disguised as functionality. Whitworth began experimenting. He measured thread angles, tested different pitches, studied which combinations gave the strongest hold and the smoothest operation. He filled notebooks with calculations and test results. In 1841, he presented his findings to the Institution of Civil Engineers in a paper titled "On a Uniform System of Screw Threads." His proposal was simple but radical. All screw threads should have a 55-degree angle between the flanks, and the pitch should be standardized based on the diameter. He specified exact dimensions for everything: the depth of the thread, the shape of the root, the radius of the crest. The response was polite disinterest. Why change something that already worked? Every craftsman knew how to cut threads their own way. Why adopt someone else's standard? Whitworth didn't give up. He knew he was right. The Industrial Revolution was accelerating. Railways were spreading across Britain. Factories were growing larger. The need for interchangeable parts was becoming desperate. Over the next decade, he continued to refine his system and promote it. He demonstrated how his standardized threads were stronger and more reliable. He showed how much time and money could be saved if parts were interchangeable. Slowly, manufacturers began to adopt the Whitworth standard. By the 1850s, it was becoming common in British industry. By the 1860s, it was effectively mandatory for any manufacturer who wanted to supply the British military or railway companies. Other nations began adopting it too, or developing their own standards in response. Whitworth had done something remarkable. He had taken an ancient invention, the screw thread, and transformed it from an artisan craft into an industrial standard. Why does this matter? Why should anyone care about thread angles and pitch standardization? Because without standardized screw threads, the modern world doesn't exist. Think about it. Your car has thousands of bolts and screws holding it together. Every single one can be replaced with a standard part from any manufacturer. When something breaks, you don't need a custom-made fastener. You buy a standard bolt that fits. The same is true for buildings, bridges, machines, electronics, furniture, appliances. Everything that needs to be held together uses standardized fasteners. And that standardization started with Whitworth. But it goes deeper than just convenience. Standardized screw threads enabled mass production. Once you could guarantee that parts made in different factories would fit together, you could specialize. One factory makes engine blocks, another makes pistons, a third makes bolts. They all come together in an assembly plant, and everything fits perfectly because everyone is following the same standards. The interchangeability of parts, a concept we take completely for granted, was impossible before thread standardization. If every fastener was unique, every product had to be built, from start to finish, in one place, by craftsmen who custom-fit each component. That limits how complex and how large you can build. Standardized threads enabled the railway age. Railway companies could order rails, wheels, engine parts, and fasteners from different suppliers across the country, confident they would all work together. Without that, railways would have been far more expensive and far slower to build. They enabled mass-produced consumer goods. The sewing machine, the bicycle, the typewriter, all depended on interchangeable parts held together with standardized screws. They enabled modern construction. Skyscrapers use steel frames held together with thousands of bolts. Those bolts are made to standards that trace their lineage directly back to Whitworth's 1841 proposal. And perhaps most importantly, standardized threads enabled innovation to accelerate. When you don't have to custom make every fastener, you can experiment more quickly. You can prototype new designs, knowing that standard parts will be available. You can scale up production without worrying about supply chains for custom components. Whitworth didn't invent the screw thread. That invention was thousands of years old. But he invented something arguably more important: the idea that screws should be the same everywhere, that standards matter more than individual craftsmanship, that interchangeability is worth the effort to achieve. The story doesn't end with Whitworth, of course. His standard became dominant in Britain and across the British Empire, but other nations developed their own standards. In 1864, American engineer William Sellers proposed a different thread standard, 60-degree angle instead of 55, with a flat crest instead of rounded. The Sellers thread became the American standard. For over a century, this created problems. British equipment used Whitworth threads. American equipment used Sellers threads, later evolved into the unified thread standard. French equipment used metric threads. German equipment used different metric threads. Nothing was truly interchangeable across national borders. During World War II, this became a serious problem. Allied forces, British, American, Canadian, couldn't easily share spare parts because their equipment used incompatible thread standards. A British tank crew couldn't borrow bolts from an American supply depot. After the war, there was a push for international standardization. In 1947, Britain, the United States, and Canada agreed on the unified thread standard, harmonizing their systems. Later, the International Organization for Standardization, ISO, developed metric thread standards that most of the world has now adopted. Today, if you're working in metric, you probably use ISO threads. If you're working in imperial measurements, you probably use unified threads. And while some old British equipment still uses Whitworth threads, they're increasingly rare. But the principle, Whitworth's principle, remains. Threads should be standardized, interchangeable, and precisely specified. Modern thread manufacturing has reached levels of precision that would astonish Whitworth. Computer-controlled machines can cut threads with tolerances measured in micrometers. Thread rolling, where threads are formed by pressing rather than cutting, can produce threads stronger than the original material. Special coatings can make threads resistant to corrosion, heat, vibration. And yet, the basic geometry, a spiral ramp wrapped around a cylinder, remains exactly what Archytas envisioned 2,400 years ago. There's a memorial to Joseph Whitworth in Manchester, not far from where his workshop once stood. It's easy to walk past without noticing. He's not a household name like Watt or Stevenson or Brunel, but his legacy is everywhere. Every bolt in your car, every screw in your phone, every fastener holding together the chair you're sitting in. They all exist because Whitworth convinced the world that standards matter. He died in 1887. having been knighted for his contributions to engineering. By then, his thread standard was used throughout the British Empire and was forcing other nations to develop their own competing standards. The age of truly interchangeable parts, the age that made modern mass production possible, had begun. One winter morning, near the end of his life, Whitworth walked through the workshops of his company, watching the machines cut threads with perfect precision. He picked up a bolt, fresh from the cutting machine, and threaded a nut onto it smoothly. It fit perfectly, as he knew it would. Somewhere across England, in a factory he'd never visited, another nut was being made to exactly the same specifications. It would fit this bolt just as perfectly. This, he thought, is how things should be. Not chaos and custom work, but order and interchangeability. Not every craftsman following their own intuition, but everyone following the same standard, building something larger together. He was right. The screw thread he standardized is still holding the world together. The next time you pick up a bolt, really look at it. Notice the precise spiral of the threads, the consistent pitch, the exact angle of the flanks. It's a small thing, easily overlooked, but it represents thousands of years of human ingenuity. From Archytas's theoretical understanding to Archimedes' practical application, from medieval craftsmen cutting threads by hand to Whitworth's drive for standardization, from industrial-age precision manufacturing to modern computer-controlled production. The screw thread is one of humanity's fundamental inventions. It's a simple machine, an inclined plane wrapped around a cylinder. But simple doesn't mean unimportant. Without it, nothing holds together. No buildings rise above a few stories. No machines operate with precision. No mass production exists. No modern world is possible. And yet for most of history, every screw was unique, incompatible, custom-made. It took a perfectionist toolmaker in Victorian Manchester to realize that the real innovation wasn't making better threads. It was making threads the same. That's Joseph Whitworth's legacy. Not the threads themselves, but the standardization. Not the invention, but the system. Not the craft, but the science. The screw thread holds our world together, literally and figuratively, and it does so because one man refused to accept chaos when order was possible. That's the invention of the standardized screw thread, an ancient idea perfected through persistence that changed everything.